Hey guys, I hope that you're all doing well. Today's lesson is about the difference of two squares. Now there's a method that I use to make sure that I master the difference of two squares, and I'll share it with you guys today. Step 1, check if there are two terms only that are subtracted. Number 2, check if both are perfect squares. And number 3, write each term as a square. Application, let's say a squared minus b squared is equal to a minus b, a plus b. Now let's do the first example and apply all these rules. The first example, x squared minus 4. Number 1, let's check if there are two terms only, x squared and 4. Your terms are separated by the plus or the minus sign. So x squared is the first term and 4 is the second term. So there are only two terms here that are subtracted. We have a minus sign here, so that meets the first condition. Number 2, check if both are perfect squares. X squared is x times x, right? Which means it's a perfect square. Then 4, you know that if you said 2 squared, that's equal to 4. But an easy way to find this is to just say, like to put square root of 4 in a calculator and your answer will be 2. When you get a whole number, that is a perfect square. So the square root of 4 is 2. So that is a perfect square. The second condition is checked. Number 3, write each term as a square. We said that x squared is x times x, right? So let's just say x, and the square root of 4 is 2. Always make sure that you verify with the calculator. Square root of 4 is 2, so let's just say 2. Now let's write down our substitution. X squared and 4, this is a and this is b. Okay, so you open the first bracket. What's a? A is x. We use this information. A is x minus b, x minus 2, open bracket, x plus 2. And that is how you factorize. Now let's do more examples. Number 2, we have 9 minus x squared. First condition, check if there are two terms only. We have 9 minus x squared. Your terms are separated by the plus and minus sign, right? So there are two terms. The first one is 1, the second one is x. That are subtracted. We have a minus here. So the first condition is check if both are perfect squares. 9, what is the square root of 9? If we put it in a calculator, then you get 3, right? Then you have x squared is x times x. So they are both perfect squares. Now write each term as a square. What is the square root of 9? 3. What is x squared? X squared is x times x. So these are your squares. Now let's write down the proof. Let's substitute. Open the first bracket. 9 minus x, 9 plus x. Now let's do the third example. Number 3, 16 minus y squared. First condition, check if there are two terms only. We have 16 and we have y squared. There are two terms. Number 2, check if both are perfect squares. What is the square root of 16? It's 4. What is y squared? Y times y. They are both perfect squares. Then the last condition, write each term as a square. What is the square root of 16? The square root of 16 is 4. What is y squared? Y squared is y times y. Now let's substitute. Open your first bracket, 4 minus y. The second bracket, 4 plus y. You substitute from that. Now let's do the fourth example. X squared minus 25. First condition, check if there are two terms only. We have x squared and 25. There are two terms that are subtracted. We have a minus sign here, so they are both subtracted. Check if they are both perfect squares. What is x squared? X squared is x times x. Therefore, it is a perfect square. What is the square root of 25? It's 5. So we've met the second condition. Number 3, write each term as a square. What is x squared? X times x. What is the square root of 25? it's 5. Now let's substitute. Open the first bracket, x minus 5, second bracket, x plus 5. Now let's do number 5. 9 minus a squared. What's the first condition? Check if there are two terms only. You have 9 and a squared. There are two terms only that are subtracted. You have a minus sign. Let's go to the second step. Check if both are perfect squares. The square root of 9 is 3, so it's a perfect square. A squared is a times a, right? So they are both perfect squares. Number 3, write each term as a square. What is the square root of 9? 3. What is a squared? A times a. Now it's time to substitute. Open the first bracket, 3 minus a, second bracket, 3 plus a. Now let's do an example that's a bit tricky. Number 6, x squared minus 1 over 4. So fractions are perfect squares if both the numerator and denominator are perfect squares. If you punch 1 over 4 in a calculator, you'll get 1 over 2, right? 1 is a perfect square and 4 is a perfect square. So number 1, check if there are two terms only. X squared is x squared and 1 over 4. Those are two terms that are subtracted. There's a minus sign. We met the first condition. Number 2, check if both are perfect squares. X squared is x times x, and the square root of 1 over 4 is 1 over 2. Both the numerator and denominator are perfect squares. So both these terms are perfect squares. What's the following step? Write each term as a square. So x squared is x times x, and the square root of 1 over 4 is 1 over 2. Now let's write our difference of two squares. The first bracket should be x minus 1 over 2, and the second bracket should be x plus 1 over 2. Now let's do the next example. Let's do x minus 1 over 9. What's the first step? Number 1, check if there are two terms only. You have x and you have 1 over 9. We have two terms only that are subtracted. We have a minus sign. So this is a difference of two squares. Number 2, check if they are both perfect squares. This should be x squared. So x squared is x times x, which is a perfect square. 1 over 9, if you put square root 1 over 9 in your calculator, you should get 1 over 3. So these are both perfect squares. What's the next step? Write each term as a square. X squared is x times x, and 1 over 9. Square root of 1 over 9 is 1 over 3. Now let's write down a difference of two squares. X minus 1 over 3, x plus 1 over 3. Now let's do the second last example, number 8. Let's do x cubed minus 16x. Okay, so we check first. Check if there are two terms only. We have x cubed and 16x. There are two terms that are subtracted. We have a minus sign, so we met that condition. Check if both are perfect squares. X cubed is x times x times x, so it's not a perfect square. From here, what do? You have to simplify this. Now, how do we simplify this? You guys should realize that this is the common factor, what we did in the previous video. So what is common here? You have x in the first term and x in the second term. So this is x, open bracket. What are you left with? 3 minus 1 is 2, x squared minus 16. 1 minus 1 is 0, so you have x squared minus 16, right? So what's the next step? For the next step, you have to check your bracket x squared minus 16. Check if it's a perfect square. Check if there are two terms only. You have x squared and 16. Those are two terms that are subtracted. There's a minus sign. So we met the first condition. Number 2, check if both are perfect squares. What is x squared? X squared is x times x, so it's a perfect square. The square root of 16 is 4, so they are both perfect squares. Number 3, write each term as a square. So x times x is x squared is x times x, then the square root of 16 is 4. Now you write this as, keep your x, the one that's outside, open a square bracket, open a bracket. Now let's solve this. This becomes x minus 4 x plus 4. That is how you solve this. Your difference of two squares was there. You just had to take out the common factor first. Now let's do the last example. The last example, number 9, x cubed minus 25x. So we check first, check if there are two terms only. We have x cubed and 25x. There are two terms that are subtracted. There's a minus sign, so we met the first condition. Number 2, check if they're both perfect squares. What is x cubed? X cubed is x times x times x. So this is not a perfect square. From here, we try to simplify this. What can we do? You can take out a common factor. So what is the common factor here? You have x in the first term and x in the second term. So you take out your x, open bracket, 3 minus 1 is 2. Therefore, x squared minus x, 1 minus 1 is 0. So it's 25. Now you should see in this bracket that there is your difference of two squares. But to be certain, let's check our conditions. Check if there are two terms only that are subtracted. You have x squared and 25. There are two terms only. Subtracted, there's a minus sign. We met that condition. Number 2, check if both are perfect squares. X squared is x times x, and the square root of 25 is 5. They are both perfect squares. The last step, write each term as a square. X times x is x squared is x times x, and the square root of 25 is 5. Now let's write down our difference of two squares. You start with this x, the one that's outside. X, round bracket, x minus 5, x plus 5. Close both your brackets. And that is how you factorize the difference of two squares. I'll see you guys in the next video about trinomials.